lesson is going to start with a little pre-calc and then build into calc. Big ideas of calc. So, hope you're on your game. Here we go. The first one is a review of your Green Book skills, solving polynomial equation. This is, hi Carver, this is something that you once in a while need to draw on. Thanks, Bob. It's not a medium. All right. So if you stink at this, it won't bite you a ton of time, but you really do need to have this down. All right. So when I say polynomial equations, typically you're talking about x's to some full powers like x cubed plus x squared plus 5x, x1, etc. Polynomials, x's to powers, right? Zeros, roots, solutions. You could have solutions. When I say solutions, I usually mean when you have an equation and you want to solve this. Solutions come in three forms. There's rational, which is to say pretty, 0, 1, 3/5, something like that. Something you can make a ratio of whole numbers. Irrational, that usually means square roots and such, like square root of 2, or imaginary / complex. 3i, negative 3i, etc. You remember that? Okay, irrational and imaginary solutions, they come from the quadratic formula usually. And so quadratic formula has that plus or minus in it. Do you agree? And because of that, irrational and imaginary come in pairs. You usually wouldn't see root 2 without also seeing negative root 2. Or you wouldn't see 3 plus 2i without also saying 3 minus 2i. They come in pairs because of that quadratic formula element. You follow? Okay? A polynomial of degree n has exactly blank solutions. So, for example, excuse me, that is a polynomial of degree what? When I say degree, I mean the greatest power in the polynomial. So, that's degree 1. And it, good job. That's degree 1, and it has how many solutions? 1. I was holding up 0, but I was trying to trick you. 1 solution. This, x squared plus 4x plus 3. That's degree 2, but has how many solutions? 2 solutions, yes? Did I say that right? First degree has 1 solution, second degree has 2 solutions, cube has 3 solutions. So a polynomial of degree n has exactly n solutions. That's called the fundamental theorem of algebra, by the way. There's an exact match between the power of the polynomial and how many solutions you have. First degree has 1 solution, second degree has 2 solutions. They don't have to be unique solutions. For example, x minus 2 quantity squared equals 0. What makes that true? 2 and 2. Really, it has a double root there, okay? So I know it feels like that only has 1 solution. It's 2 solutions. It's just, they're not unique, okay? So the rule isn't violated. Because irrational and imaginary solutions come in pairs, okay, stick with me, this requires a little deduction on your part. Because imaginary and irrational solutions come in pairs, any odd degree polynomial must have at least 1 ... what solution? Okay, so a cube, how many solutions would it have? It has 3 solutions, right? Now, if 2 of those are imaginary, or 2 of those are irrational, then there's 1 that must not be imaginary or irrational because it doesn't have a pair. It doesn't have a pal to pair up with. So it must have at least 1 rational solution. Okay? All right. Review. And this was 4 lessons in the end of the green book, if you remember. But we're going to just give you a refresher and combine a lot of it into one. All right, so when you solve a polynomial equation, first thing you try and do is factor if possible. Not everything factors, but sometimes problems are set up nicely so you can factor it, because factoring is awesome and useful. Okay? If it's not obviously factorable, and you'll gather the possible rational roots. Now, would you please write the rational roots theorem? Solutions must be, or must come from, combinations of factors of the last number in the polynomial divided by factors of the first. Let's do an example here. Just to remind you, 3x plus 2, x minus 1. Okay? Do you agree that the okay, so check this quadratic out. This quadratic factors that way, okay? What are the solutions? What are the roots? What are the roots? 1 and negative 2/3, okay? Now then, those aren't just 2 and 3. Where did that come from? I don't know. Those came directly from, that 2 came directly from that 2, factor of the last. That 3 wasn't random. It came directly from factors of the first. Okay, all solutions, even on cubic level, come from combinations of factors of the last over factors of the first. That's the rational roots, all right? Could be positive or negative combinations of those. After you decide, all right, these are the things that might be solutions, rather than the old, all right, I'll try plugging 2 in and see if it makes it 0, or I'll try plugging 8 in and see if it makes it 0. For a solution, an equation like this, maybe not too bad, but for a 4th degree equation, plugging and chugging, that's miserable. So instead, to see if it makes it 0, we synthetically divide and see if the remainder equals 0 or not. If the remainder does equal 0, then boom, you just found a root that divided in evenly. After you find a success, if a 0 remainder is found, then that means that you just divided something out. And if you had, say you were solving a cubic, if you found a solution that worked, then you could say, all right, I found one solution that works. The rest of the stuff must be, if I take x cubed and divide out an x, I'm left with an x squared equation. Now that's called a depressed equation. After you divided out something successfully, the what's left, the quotient, is called the depressed equation. You then try and solve the depressed equation. All right, so all that, I know I'm going fast, but it's review, so you better be good. Let's do 2 together, shall we? Sounds great, I'm ready. Look at this one. X cubed minus 4x squared minus 2x plus 8. First thing I said you should do is try and factor. That does factor. Do you remember the factoring method there? Okay, it's called factoring by grouping. And the name of the game is GCF, greatest common factors. But only in little neighborhoods. What's the greatest common factor in that little neighborhood? X squared, leaving you with x minus 4. In that neighborhood, you could say the greatest common factor is either 2 or negative 2. Now, why would you take out 2? You want to take out a 2, the reason being so that I'm an idiot. Not 2, but you want to take out a negative 2. No wonder you're confused. You want to take out a negative 2 so that when you do, this is exactly like that guy, so that now you have a new greatest common factor. They both have x minus 4. When you take x minus 4 out, what are you left with? X squared minus 2. Now you're dealing with a little smaller parts. Either x must be 4, obviously that equaling 0 would cause the whole thing to be 0, or x squared minus 2 could be 0, causing the whole thing to be 0, which would imply that x is, run it in, root 2, positive or negative. That was a cube. How many solutions do I have? 3. 3 solutions to a cube. Okay? Now that one factored, so I didn't have to do any rational rootsy, synthetically dividing kind of stuff. This one doesn't have any factoring by grouping here. No matter what kind of greatest common factor I tried here, x squared, I'd have x minus 1, but there's no way I'm getting an x minus 1 there. This factoring by grouping isn't here, it's written. So instead, no factoring here. So now, instead, we're going to do it the other way. The possible solutions are x equal plus or minus factors of the last. What are the factors of the last number? 1, 2, 4, and 8. Divided by factors of the first number. Factors of the first, in this case, are just 1. So, although it seems like, oh, there's so much work, to me that's great. You just took an infinite number of possibilities and boiled it down to 8. There are only 8 possibilities. Positive or negative, 1, 2, 4, and 8. Let's give it a go. Do you remember synthetic division pretty well? Okay, the first thing you do is write the coefficients. 1, negative 1, 2, and negative 8 there. You then divide. It's kind of like matrices in that you don't write the variables. It's just a way of writing it quickly. You strip off the variables and just write the numbers in the problem. So let's try 1 first. What do you say? All right, what's the synthetic division process? What do I do first? Drop the 1. And then multiply, record it in the next column, add. Multiply, record it in the next column, add. Multiply, record it in the next column, add. Now is that success or not? No, we're looking for a case where the remainder or the last number is 0. So that's a no. However, I do know that a cube should eventually end up in positive territory. So I'm going to try 2. Try 2 on your own and see if we get a bingo. I get a bingo. How about you? All right, did you get a 0 remainder? All right, now about that depressed equation I spoke so quickly of. What I just did is when I divided this by 2, I really just divided by x minus 2. So I took that cube and divided out in x minus 2. And when I divide, kind of like this, really. And when I divide x cubed out by an x, I get an what degree? What's x divided by into x cubed? X squared. The result, which is right here, that's called the depressed equation, or a lesser degree equation. The depressed equation is x squared plus x plus 4. What would happen if I multiplied this all back out? What would I get? Yeah, I'd get that original equation. This is exactly equal to that, but this one's easier to solve because right away I know 2 is a solution, and instead of dealing with a cubic, now I'm dealing with the quadratic. How can you figure out the zeros of that? Doesn't factor, so quadratic formula. I could find the solutions by saying negative 1 plus or minus b squared minus 4ac over 2a. X is negative 1/2 plus or minus, what do I got in there? Simplify that root for me, please. power n answer. Negative 3 in the root, which means 3i over 2. Okay? Now then, that combined with the 2 is 3 solutions. 2 imaginary, 1 real. What would you know about the graph of that? If I looked at the graph of that, what would you see? You'd have one x-intersection, right? Or x-intersection. Good, thank you. Okay. Now, let's connect polynomials to calculus. If I looked at end behavior of polynomial graphs, x squared looks like this. X to the 4th could look like that, but could take a little more turns. But most importantly, the end behavior is up and up. Even powers go up and up on the outsides because positive numbers to even powers would be huge positives, but negative numbers to huge positives would also be positive numbers, right? What about x to an odd, like x to the 1st, which is linear, or x to the 3rd, which is something like that? End behavior that is up on the right and down on the left, because a negative to an odd power is going to be negative. What about if you had a lead coefficient that was negative, negative x to the even? Instead of going up and up, it would go down and down. Negative x to an odd. Instead of going down to the left and up to the right, it would be the opposite. It would go up to the left and down to the right. Negative x cubed, yeah? Max number of turns. X to the 1st looks like that. How many turns does it have? 0. X squared looks like that. How many turns does it have? 1. X cubed could look like that and have none, but it could take up to, how many turns does that have? 2 turns. So the general rule of thumb is the max number of turns for an x to the n. X to the n has a max number of what turns? N minus 1 max turns. Doesn't have to take them all. It would depend on, do they have other terms there to make it? Dipsy-do. Okay? Basic graph shapes. Here we go. Y equals ax plus b. What does the graph look like? Well, it's linear. Yeah. If a is greater than 0, then it would look like that, positive slope. If a is less than 0, then it would obviously negative. Cool? Ax squared plus bx plus c is a parabola. It could be a parabola opening up if a is greater than 0, or a parabola opening down if a is less than 0. A cube. A cube could take absolutely no flat spots, 1 flat spot, or 2 flat spots. Now that flat spot thing, I'm going to talk calculus at you in a minute. Those are all cases where a is positive. So it goes up to the right and down on the negative side, yeah? If I did a is less than 0, then I'm talking a negative x to the odd. It would go down to the right and up to the left. With me? All right. Ax to the 4th. It could, by itself, just x to the 4th, looks like a parabola, though it's steeper growing. It could take some WE kind of turns, could take up to 3 turns, could take less. Could do stuff like that. The greater the power, the more possibilities. All right, now let's talk calculus. In this case, what's y prime? Y prime is A. Okay. Now I want you to focus on, when I say calculus ideas, focus on how many times can the derivative equal 0? Now the reason I want to know where the derivative is 0, because where the derivative is 0, that's where the graph has a horizontal tangent. Remember, the derivative is the tangent slope. If the derivative is 0, then that tangent slope is 0, and that means a flat spot. Now, flat spots are huge for calculus, and we'll talk about that on the back side, right? Now, in this case, going back to the linear, we said the derivative is a. That cannot equal 0, so the graph has no flat spots, or no horizontal tangents. That also then to say that it has no mins and maxes, because you can't get a min or a max unless it has a flat spot. Let's go to the derivative of a quadratic. What's the derivative of ax squared plus bx plus c? 2ax plus b. Now, if I were to then set that derivative equal to 0, how many solutions would I get? One solution. A linear equation has one solution. That would imply that a parabola has one flat spot, which we know to be true. A parabola has exactly one place where when I say flat spot, I'm saying the tangent line would be 0 there. Exactly one. Okay? On a cube, what's the derivative of a cube? Y prime is, what's the derivative on that cube right there? 3ax squared plus 2bx plus c. Okay, now that's a quadratic. If I set that equal to 0, I actually have lots of possibilities. It could have two solutions. If it has two solutions, which it could have, I mean, it could factor nicely or something, you know, it could have 2 and 3 solutions. But which of those graphs would have two places the derivative is 0? The first, the second, or the third? The third. That has two places where the derivative is 0 because it has two places the derivative or the tangent slope goes flat. So this would be a case where the derivative had two real solutions when you set it equal to 0. It's possible that a quadratic can have exactly one real solution, a double root kind of thing we talked about. If that were the case, then that would correspond to that. It kind of faked you out. It felt like, oh, it's going to take a turn. Oh, no, it went back to growing. It had a flat spot, but it didn't pan out to be a min or a max. Okay? Now that is to say then that a flat spot doesn't guarantee a min or a max. It's just a great place to look, and sometimes it's a max or a min, but it doesn't have to be. You need more than just flat, and we'll talk about that on the back side. It's also possible that it has no real solutions. It has to have two imaginary solutions or two solutions of some sort. But if it has no real solutions, then that would mean that the derivative has no real zeros, that there are no tangent zeros, which is to say no flat spots, and therefore no extrema. You tracking? Last but not least, what's the derivative of x to the fourth, that equation? Y prime is 4ax cubed plus 3bx squared plus 2cx plus d. Okay? This could have three real solutions. Possibly. In that case, which of the three pictures would that match with? The first, second, or third graph? Derivative zeros mean tangent slope is 0. Tangent slope is 0 means graph goes flat. How many places does the graph go flat? Right there in graph 2. Okay? Does a cube have to have at least one real solution? Yeah, every cube must have at least one real solution. It cannot have three imaginary solutions, because then there would be an I in the problem somewhere, all right? If it has to have at least one real solution, it must have at least one flat spot, and that's true for all these. Every one of these has to have at least one flat spot because there's no way to go up and up without turning once at least. You follow? Okay. I just added a bunch of pages. All right. Here we go then. All right. So this is a huge idea of calculus. The derivative tells you a lot about the function. Okay? If I ask you to find where a polynomial is increasing or decreasing and justify why, you're going to have to go about that without even knowing the graph sometimes. If you graph any function that's increasing, say this, or this part of a parabola, what do you notice about the tangent slopes at anything that's increasing? And when I say increasing, I mean as you go left to right, the y's get bigger. What do you know about the tangent slopes in every case? Tangent slope is positive, okay? So if the derivative function is positive, the function is increasing. I'll say it again. Increasing, f increasing means f prime positive. F decreasing means f prime negative. If f is neither increasing or decreasing, it's momentarily flat, then f prime is 0. That is huge. Those three ideas are huge. Put little stars around it in your notes and put an arrow. Okay, and then get a tattoo of that. All right? Don't really get a tattoo. That's ridiculous. That's terrible. That's a bumper sticker and a Ferrari. All right. Instead, let's go with this. If I ask you to find where this thing is increasing, you are not going to do this at all with your graphing calculator. Don't need it. It would take you longer to put this in your calculator than it would take for me to do this without a calculator. All right? To find where this is increasing, you need to know where f prime is positive. To find where f prime is positive, you're going to have to do a three-part process. First, you'll need f prime, obviously. It's going to be hard to see where something's positive if you don't have the thing. The next thing you're going to do is find the zeros. Where is it 0? And then sign test to see where the derivative is positive. Okay? So let's start by finding the derivative. What's the derivative? With a good label, f prime. The derivative is negative 7x squared. What else? Minus 14x. What else? Plus 21. All right? So we find the derivative. We set it equal to 0 and solve. So what do you want to do first to solve this baby? Factor out a negative 7. Okay, so this is my warning to you. Okay? When you say factor out negative 7, do you mean take negative 7 over to the other side and dump it forever? You don't mean that. Please, I beg you, never do that. I'll explain why in a second. But for now, say dump it. The answer is an emphatic no. Do not dump it. Do not divide it all the way over. Factor it out front and leave it out front. Right? Now, when you dump that, or when you factor it out front, what do you have? X squared plus 2x minus 3 equals 0. Cool. Negative 7 stays. How does that factor? X plus 3x minus 1. Feel free to speak up. Okay. Now, I've got my zeros. My zeros are certainly negative 3 and positive 1. Wait. Okay. According to the test, we need to go over sign testing a little more. So, on the test, I had people find the zeros, but then they put a whole number line that I don't, no. Okay, you need to actually, you found these not for the fun of it, but so that you could use them. You will put them on the number line and only them. Nothing else matters, just the zeros, okay? All right, negative 7 obviously can't be 0, so there's no 0 there. It's 2 real x zeros, right? When I put in a number over here, like -8. What do I get? Well, the -7 is negative. -8 plus 3 is negative, and -8 minus 1 is negative. And that, then, overall is negative. Now, if I dump that -7, then what sign would I have got there? Positive. You would have just got the exact opposite conclusion. That's why you don't do like you would normally say, just dump it forever. That's got to stay because it affects the sign test. You've got to keep it. Okay? What about inside here? Maybe 0. Negative, positive, negative. What's negative times a positive times negative? Positive. And what about at 7? Negative, positive, positive. Negative. Okay? Now let's answer the question. Find where the function is increasing. The function is increasing on what interval? F is increasing, let's say it in a sentence because that's typically how the AP works. F is increasing on what interval? -3 to 1 because F prime is positive. F is increasing where the derivative is positive. Okay? Now don't worry about the endpoints. It's actually neither increasing nor decreasing at the endpoint, so I wouldn't include them. Although the good news on the AP tests, if it did include them, they wouldn't take up, right? Are you with me? Okay, let's try one instead of analytically, graphically. Find where F is decreasing given the graph of F prime. This is F prime, all right? So F is decreasing where what is going on with F prime? Where F prime is negative. F prime is negative where its graph is below the x-axis. So we'd say F prime graph below the x-axis. Now all that's just our thought process. On the AP test, I wouldn't actually be writing that. I would just give my answer. F is decreasing on what intervals? I think that's a -2. Talk to me, people. Give me one interval. -2 to 0 and 1 to infinity because F prime is negative. And you could say the words F prime is negative, or you could write F prime, I guess, and 0, both are accepted. Are you with me? Okay. That's the case because anytime F prime is negative, F tangent slopes are negative. All right. Last but not least, howdy. All right. Then, big idea of calculus. Check this out. This is called the first derivative test, and it's crucial. Boy, did you time this right. I'm going to keep extra treat for you here. If the sign of the first derivative changes from positive to negative, the function must have a relative max there. Now, here's why. If the first derivative is positive, then what do you know about the function? When the first derivative is positive, the function is increasing. When the first derivative is positive, the function is increasing. So if the first derivative goes from positive to negative, then the function goes from increasing to decreasing. There's got to be a max. If the first derivative changes from negative to positive, then the function changes from decreasing to increasing, and there's got to be a min. Relative min, we'll talk, I should have probably already got this in there, but relative min is a necessary clarification because when I say this is a relative min, it's relative to that little area. Do you agree it's the minimum value in that little area? But it's most definitely not the minimum value of the function because the function goes much lower later, yeah? This doesn't have what you would call an absolute minimum. This is a relative or local min. If you can define a sub-area that has this characteristic, that it's a relative min. All right? So, find the x values where the extrema of. Now, the extrema is min or max, the extreme values, justifying with the first derivative test. First thing you have to do is take the derivative. What's the first derivative? Negative 4x cubed plus 9x squared, okay? Now, we're going to proceed on to that and find where did the graph go flat? Because the graph goes flat is a darn good possibility for a minimum max. We find where the graph goes flat by setting the derivative equal to 0. Right? So how would you solve this equation? Take out an x squared, leaving you with negative 4x plus 9. And your solutions are x equal 0 and what else? 9/4 or negative 9/4? Which is it? 9/4. Okay? All right. Now, this then is gold because I just found places where the graph goes flat. Now, I want to do a sign test on f prime. Place the zeros. 0 is left of 9/4 on the number line. Give me or test a value less than 0, like negative 2. At negative 2, x squared, well shoot, that's always positive. Negative 2 here. Negative 4 times negative 2 plus 9. Is that positive or negative? Negative 4 times negative 2 is 8 plus 9, that's positive. So, f prime is positive in that interval. What does that mean about f then? If f prime is positive, then f is increasing. If the derivative is 0 there, then the graph goes flat momentarily. Now we're going to see, all right, now does it turn down or not, or does it go back to increasing again? So test in here, maybe 1, positive, positive, still positive. Okay? And that then is positive. So it tricked you, or tried to trick you. It went back to, the function went back to increasing. At 9/4, once again, the graph goes flat. After 9/4, like at a billion, x squared is positive. What about negative 4 billion plus 9? Negative or positive? Negative. And now you get a negative first derivative, which means the function is, if the derivative is negative, the function is decreasing. With that then, we can decide that f must have what? A min or a max? A max. Where? At x equal 9/4. Okay? Now, the last part then is a conclusion. This is required. The first derivative test implies that the last step is a sentence. You would say something like, f has a max at x equal 9/4 because, then the first derivative test. We're satisfying the theorem. The first derivative test says that if the sign of the first derivative goes from positive to negative, the function must have a relative max there. Your evidence then would be f has a max at x equal 9/4 because f prime changed from positive to negative. Now, as much as I'd like to say that means the function is increasing and decreasing, just the first derivative goes positive to negative, period. Okay? Notice that there is never a single pronoun here. Never use it or any pronoun in any calculus ever. You'll never say it changed from positive to negative because it could mean the derivative, the second derivative, the first derivative, the function. Doesn't mean anything. Never a pronoun. All right? Let's try 2 on your own then. Go.
over the test tomorrow.
These do help you, you know. Got steps up there, use them. This one? Good. Okay. All right, gentlemen and ladies. Hi, Ms. Carver. I'll do a little first derivative test for this. There's still one. No, I just got a mistake in my test. How many extreme are you getting? 3. You're getting 3, you're on the right track. Okay. Can I give you a little, sometimes pointer that's there for the sign test? It can be tedious doing the sign test. It might help if you think graphically. If I were to show the shape of the cube, doesn't a cube shape look like this? Yeah? So if this has 3 zeros, wouldn't it have to look something like that? So I could actually use that shape to say the derivative is negative, then positive, then negative, positive. Either way, though, your sign test should communicate that negative, positive, negative, positive. Yeah? Are you with me? All right, then. That's what the first derivative signs are. If the function then, now let's think about what the function is. When the derivative is negative, the function is decreasing. Graph goes flat. When the derivative is positive, the function is increasing. Graph goes flat. When the derivative is negative, the function is decreasing. Graph goes flat at 1. And when the derivative is positive, the function is increasing. With that little doodle, it's easy to see what's mins and maxes, but you still have to conclude. Now the good news is that you can write those two mins together. Do we agree we have mins at negative 13 and 1? You can put them together so you don't have to write 3 sentences. F has relative mins at x equal negative 13 and 1 because what? That mins because the derivative changes. -2.
Good morning, Devon Jaguars. Please rise for the Pledge of Allegiance. Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Please be seated.
So your max conclusion.
Students, seventh graders whose last names are Gardner to Lucero, please report to the auditorium for the assembly.
Relative max at x equal
Tomorrow, last names.
0 or 1. Oh,
Congratulations to marching bands for an outfit.
0, yeah. You're right, sorry, I don't know what I was thinking. 0 because
3A, and they absolutely nailed it. Congratulations on our first place in 3A.
from positive to
Interested in traveling to Costa Rica?
negative.
Stop by Senora Stevenson's room for more info.
Try the graph.
First parent teacher meeting will be tomorrow, Wednesday, September 19th at 6 p.m. in the Bear Creek Lecture Hall. Today, counseling during 7th hour, University of Arizona will be here to speak with prospective students. Notable are Courtney Kardashian and Kristen Wiig. Tomorrow, Colorado Christian University. There are various upcoming college information nights, not a deadline, for students and parents who want more information. Check the See What's Happening bulletin board at the cafeteria. You'll notice MIT, University of Virginia, Princeton, USC at Berkeley, Dartmouth, Brown, Cornell, Columbia, and more. Senior high students. Students receive an academic letter for earning a grade point average of 3.5 or higher during the fall and spring semester of the school year. If you accomplish this, your name should appear on one of the documents hanging on the front door. This award is different from the honor roll, which is earned for one semester of 3.0 or higher GPA. Please let Mr. Podcast know if you earned an academic letter that your name does not appear on the list, so we can correct the award ceremony program. Seniors, if you're interested in applying for the highly selective Betcher Scholarship, please come down to counseling today during 7th hour to take the competitiveness quiz and to learn more about the process. Remember, this is a very competitive scholarship and is only awarded to students who will be attending college in Colorado. The 2018-2019 mock trial team is preparing to repeat as state contenders. If you are interested in joining us, please attend an informational meeting on Monday, September 24th at 6 p.m. in Mr. Carson's room, 2nd floor west. Parents are welcome. Since this is a short one, no dinner will be served. Seniors, another reminder, this Friday is the last day to submit baby pictures. Stay true to the tradition and submit them via the yearbook button on the Devlin homepage. Submit your pics or you'll be sad and cry. Last chance. Junior high students, attention all 8th graders. Be a part of the first ever Cyber Patriot Club here at Devlin. Learn how to secure and defend computer networks. Be a part of a team, gain skills, and more. The first informational meeting is Friday, September 8th. From 2:45 to 3:30 p.m. Computer lab next to the library. See council if you're interested. Also, don't forget to attend the softball game today. That's all your announcements. Have a great day.
Okay, hang on. You have a couple minutes still. So F has a min at where? Where does F have a min? Does it have a min at -3? No, the derivative goes positive to negative there, which would imply the graph went, F's graph went increasing to decreasing. So not there, that's a max. It has a min at 5 because F prime changes negative to positive there. That's where the graph goes from below the axis to above the axis on the derivative, meaning F goes decreasing to increasing. Max at x equal -3 because F prime changes positive to negative. Okay, one last thing here. I have the key to 70 or 30, what is it, 32 online. I gotta warn you, some of you are not even close to getting enough help, okay? You need to get help. I don't have time to go over 30 minutes of questions in class. It doesn't work. In order to prepare yourself just for college, okay? It's not going to get any easier than a professor being in the building and willing to help you for an hour every day. That's not how college works. In college, you're going to have to go across campus, in there 2 hours a week to get help. Grow up and get help while you need, okay? Please, I beg you. Yes. That's not it. It's back here.
I know this is the beach. I'm in danger. Where were you yesterday?
All right. So let's make a little resolution.
What? Where were you yesterday?
Most of the time. Yes. The notes online, but for us, Hi. Hi, dude. That's sick. Okay. You're welcome. Have a great day. Haley killed the test, man. You have an amazing, yeah, great calculus, man. I can't believe you're not in honors. Why weren't you in honors?
I took smaller last year.
Why weren't you in honors?
It's a little late for that.
I understand it's late, but you should have been in honors the whole time. You're really, yeah, amazing man.
I want
Really
this
good.
calculus.
Oh, not at all. Okay, you're doing really.
Can you teach me calculus?
I can in 6 years, 5 years. It takes a little, you need a whole lot of stuff before that. It's like teaching you how to fly before you can walk. First you have to walk, then run, then fly. That's neat.
People can't fly.
You can't fly into flying. I know, it's just a metaphor. Hi. I just maybe did it so I wanted to finish. I did not wait, I got to 4:30. I just have a lot to do. You get your stuff done? Do you have a test today? Are you ready? 2 tests today? What are your tests in?
Do you have picture of
Oops. English and stats. What stats? The normal district.